And we're back again. So we were talking about sort of factoring out a little bit of the rendering into so that the renderer doesn't actually know what object it is sort of drawing. Because right now we're like specifying the vertices directly here and sending the data at it, which is not really what we're looking to do. So this is sort of a good question. We're just going to clean up this code a little bit because we don't need a lot of this stuff anymore. So right now, the way we're drawing is we set up some vertices here. Then we generate a GLES buffer. We bind it and we transfer the data into it. So in order to sort of render an object, what we kind of need to do, and it would be nice to have the object itself not know anything about like GLES, so we'd like it not to call this stuff, but still sort of the buffer of vertices is really dependent on the object. So that's a good question of how we're going to do that. It's probably going to be something along the lines of that we have a kind of a model class which represents the actual physical or the actual object being rendered. So that would be sort of like a cube or whatever. And then we're separate from that going to have sort of the internal representation of what that object is. And the renderer will know about the actual object and will know how to render that. Or the actual model. So I think that's sort of the route we're going to go with it. But the first thing I'd like to do is I'd like to actually get more than just red on this wonderful triangle. And we're going to do a little modification of the vertex shader to help us sort of visualize what's going on. Or the fragment shader. So here we just assign sort of a constant color to the fragment. So what we'd like to do is we'd like to sort of, for every vertex, we want to calculate sort of a vertex color. So that is what's called a varying. And it's going to be a vector 3. We're just going to call it color. And what we're going to do is we're going to take our vertex attribute here. And we're just going to start by doing a little bit of nasty assumption that our vertex is always, like, all the coordinates are between -1 and 1. Because that's sort of where we're going to start out working. That means that we can pick a color based on our vertexes X, Y, and Z. We can multiply them by 1/2. And then add 1/2 to each of them. That should add some color. And then that will be interpolated across the entire surface. So in our fragment, we can, instead of doing anything fancy, we just set the fragment color to be the color. And just declare that we have this varying vector coming in, like this. And technically, yeah, we're going to do it a 4-dimensional vector because it should have a 1 at the end. So we're going to take a 3-dimensional vector and then we're just going to make it 40 here. And at some point, I'm probably going to discover that this has a massive penalty in form of performance, but we'll worry about that when we'll worry about that. So hopefully new. Well, that was beautiful. So let's just have a look at what we're doing. Where is, there's my render. So like all of these coordinates are between minus 1 and 1, so that shouldn't be a problem. So for some more or less annoying reason, this doesn't seem to be working. So if it wasn't for the fact that I'm actually getting a GL error of 0 indicating nothing wrong, I would say I probably got a compiler. Could of course just check that I actually get an error on a compiler error, and this is where I need to get it to clean out a little bit to make sure that it'll actually copy the new assets over. Yeah, that doesn't give me a GL error. That's wonderful. So we're going to start by instrumenting our shader code a little bit. So when we do these compilations, I used to have a nice little GLES quick reference. This thing. Because there is a set of here shader objects. So when you query or compile stuff, you can get a log from the compile process. So here it is for the program. It has this like get program info log. There should be a similar get shader info log here. So when we do that, okay, I'm still doing that, but fair enough. So what we're going to do is we're going to create a quick little buffer here that we're going to use to store some stuff in. So we're going to call GL get shader info log. We're going to look at our shader that we've just got allocated. Our buffer size is 65536. Then we have a resulting length. And then we have the info log itself, which is the buffer here. So what we want to do is we want to have a size t length. And then we are going to output this buffer. So shader, compile, info. Just gonna give ourselves a new line here. And then we're gonna output a standard string based on the buffer and length. So it'll be the first length characters of the buffer, just in case they don't null terminate. Pretty sure they do, but just in case. Okay, so they just, GL size I. That'll be fun. Try again. So let's try and run that and see what it says. No precision specified for float, which is an error. Because I need to say something probably about the precision of that vector. So that is something like saying varying low precision, I think, is the syntax for that. Again, let's just clean out so that we get a new assets package. And rerun. There we go! We now have a nice colored triangle. So you can sort of see which directions the various colors are in. Great. So from here we can then move on and try and add some other stuff, because what we want to do is we want to move from just sort of, right now we're just drawing an entire float of vertices. We want to move this over to sort of having a buffer of vertices and then just indexing and saying that one, that one, that one, that one in that order. Because that allows us to reuse a lot of vertices. especially if we keep vertices away from normals, because we might reuse vertices but with different normals. So that will allow us to be a little bit more efficient when we get to like shading and stuff like that, and we want to have surface normals so that we can sort of shade things correctly and do highlights and stuff like that. But for now, we're just going to try and see if we can't get it set up so that we have an element buffer. And the way we do this is quickly transition over here. So we had these wonderful vertices here. So we've been using this draw arrays. There's also a draw elements, which is the one we want to do. And that means we have to bind an element array buffer. Right now we're just binding array buffers. So we're going to try and transition our code to do that. And the way we do that is we do a GL int. So these are then going to be the elements that we want to. And for now, we are just going to draw elements 0, 1, and 2 in that order. So we generate a buffer, we bind it as an array buffer, and then we program that with static draw for our vertices. Now, just to be consistent, vertices and elements, we are then going to want to generate another buffer. And this is not going to be an array buffer, but an element array buffer. So we're just going to quickly call this thing something else. So this is going to be the E buffer for element buffer, which we then load our elements into. And this is going to be the size of GL int. So we load that into our element array buffer. So we do a lot of stuff here. I don't like that bind call, but I'm a little bit scared to change it right now. So rather than GL draw arrays right now, what we do instead is we do GL draw elements. We're still going to be working in triangles mode. We are going to start, so the first count type, and then so either unsigned byte or unsigned short as the type. Well, then unsigned int is probably a bad size to use up here, or ints. So we're probably going to want to do GL shorts. So we are going to use, these are going to be GL unsigned short, which means these should probably be GL shorts. That's going to make a massive amount of difference, but it's there. And the indices. So I also have to give it the count. We have 3 elements, and I want to start from element 0. So that should, in theory, draw the same thing we've drawn all along. And it actually does. I'm always surprised when things work. That way you get a lot of surprises. Or at least that's what you hope. So in principle, if we now play around with these vertices a little bit. So far we've been drawing a triangle. If we now just quickly change these around, like that, now we have a square. If we just draw elements 1, 2, 3, we are going to get half of that quad or triangle, or square, or what you want to call it, as a triangle like that. And then I should be able to say that, oh, and we also want to draw 1, 2, and 3 as a triangle. we're asking for triangles, so this is sort of the way you do it. And if we refresh, we should have a square, and we don't, which, oh, yeah, I'm still saying 3. You know what? This should probably be size of elements. That will be the number of elements in elements, which is always a good thing. So with that done, we refresh that, and we get a square. Nicely colored little quad here. Isn't that just wonderful? Couldn't be more beautiful than, well, probably could. So that's sort of what we want to do. Yeah. I just want to try and kill off that bind buffer there, because I'm pretty sure that's not, doesn't need to be there. Probably get unsupported operation or something like that now. No, still works. Good. So what we're doing now is we declare our vertices, then we declare the order of that our triangles want to use these vertices in. Then we're setting up our transform matrices. We generate buffers here with the data in it, which probably shouldn't be done every single time, but just once. And then we ask it to use a specific shader program. We set our transform and camera models. We find our vertex attribute so that it works our way through. Yeah, we enable a vertex attribute array, which means that whatever is bound at this point to the array buffer, namely this, will be our vertex, or will be bound to this vertex attribute location. This is in no ways confusing. So that's what we're doing right now. So what we want to do is we want to sort of factorize some of this stuff out. And the easiest way to do that is probably that we are going to do a simple little C++ class called a block. It's going to be really the simple way of doing it. We're going to have a constructor that's public. And then we are going to have a void function called render, which is going to be constant because that's not meant to do anything. And then privately, we are going to have various little things here. So one of the things is that we are going to have a, well, first of all, we are going to use GL_this2, GL2.h. We are going to have some GL floats. Oh, float vertexes. We're going to have a set of GL ushorts, which are going to be our indices. I might have spelled that wrong, in which case, tough cookie. Now these are sort of static data. That's just going to be how we render, or data about how we render a block. In addition to that, we are going to have our own little bit of information about our buffers. So we are going to have a vertex buffer and an index buffer. At least that's the idea. So what we want to do is we're going to try and see if we can't replace a lot of this stuff. So we're still going to be setting up our viewport here. We are still going to get our model and camera transforms. We're still gonna set up the program and set up our transforms here. Now the interesting question is, do we leave this to block to know that it has this, know which shader program it's associated? Well, since we're sort of setting the shader program on over here, we are gonna want to say that this is probably something we give into it. So that means at this point, we are gonna pass in a vertex attribute location to our, so this is our vertex attribute, double T, vertex attribute, allowing us to set our vertex, and then basically all of this stuff is going to get moved. So we're just gonna pull this in as a sort of little memory aid. And then over here, we're gonna instantiate a block. And then we're gonna ask that block to render. And I think I copied a little bit more than I needed to, because I want to grab this vertex location and pass in. So what is a block? Well, a block is this weird thing that we're working on. There we go. Now we should get lots of compile errors. Unresolved symbols, 2 of them. So what we want to do is to make our block, we're going to need some vertices. So these are GL floats. So our vertices are 1 float, 1 float, 1 float. I'm going to leave a little bit of extra space here. And it removes that for me, so that's just great. We need 8 different vertices. And we're going to set them up like this. So these are the 8 vertices of a... Yeah, and I need to say like that, and there we go. Vertexes. So the next question is, what is the order we need to draw them in? So to draw indices, to draw our, okay, we're going to be drawing triangles. So for our first surface, we are going to use index 1 or 0, 1, 2 for the first triangle, and then we're going to use 1, 2, and 3. So that sort of gives us the front one, or the one with all of them saying x is 1. Then there's another set with all of them x being -1, which means that we use 4, 5, 6, and 5, 6, 7. Great. Then we need a pair that's all the ones with y, so that means we do 0, 1, and 4. And then we do 1, 4, and 5. And also we have the one with the negative, so that's 2, 3, and 7. And then we go 3, 7, and 2, 3, and 6, 3, 6, and 7. And finally the one with z being positive and negative, so that is 0, 2, 4, 4, and 2, 4. I'm not writing this right, 2, 4, and 6. And the one with the negatives is 1, 3, 5, and 3, 3, 3, 5, 7. So that's sort of the raw values that we need. So now when we create our block here, so in our constructor, what we're going to want to do is we're going to want to generate these buffers. So we're going to start with a vertex buffer. So we have we have a V buffer, which we're going to start. This is just our array buffer. And we bind that, and into that we want to load our vertices. These are just static vertices that basically we could share these buffers between all blocks essentially, but right now we're just going to look at the one. And then we're going to want to do the same with the index buffer. So that is this index buffer. And for this, we're going to be using the indices. There we go. We want to put those in. So that's sort of what we do ahead of time here. So to do an actual render pass, we go for our block render function here. What we want to do is we want to set we already have the vertex attribute. So at this point, let's check with our renderer. So it's gotten the attribute location. We want to set up a pointer and enable it for arrays, and then we want to draw triangles. So we have our vertex attribute here. 4 floats has size that, and that's the size, and we don't want to do any stuff. So we want to enable that to use our vertex array, the one we've got bound. So at this point, we technically want to bind the vertex buffer here. And then we want to make sure our index buffer is bound here. And we are going to use size of indices here. And that should in theory work. So let's see what happens. Well, we've got something. I'm not sure it classifies as a cube, but it's definitely something. Looks like some sort of pyramid thing we've got going on here. Kind of looks like I might be behind me. So yeah, clipping planes are apparently a thing. I can't really figure out what it is we're drawing, but we are definitely drawing something. So our vertices are all between 1 and -1. And it's not like we did something else before. We'll put it here. Yeah, I figured we were missing something. We're missing the wonderful, wonderful little W coordinates here. That explains why it's looking weird, because then the perspective transform does weird shit. And that is why it's going really, really horribly wrong, probably. So yeah, we have a cube. Now, you'll notice one thing really, really quickly. We're kind of seeing through the cube and inside it and outside it, so it's kind of a little bit weird. at times, but that has to do with the draw order, where right now we're not really. Thing is, if you're drawing something, you want to draw closer things on top of further away things, and right now we're just drawing things in some order. So that's kind of the problem. So what's happening here is like the far plane, the one on the far side of that cube, is being drawn after the one near us. So we're getting this really wonderful effect. And that's because we're basically drawing this set of points before this set of points. And these ones are, I think it's these ones, are further away than these are, which causes this. So, to sort of fix that, there's a thing in at least classic OpenGL called depth testing, where you write to a depth buffer. So like every time you draw a pixel, you write its depth into the scene onto basically an image. And if it turns out that next time you come to write a pixel at the same position, you sort of sample that, and if whatever you've written there is closer than what you're about to write, then you don't write anything. And if it's further away, then you write your current pixel value. So depth testing is probably what we want. And here, per fragment operations, depth buffer test. Right in the documentation, just what we're looking for. There's also like blending functions and scissor testing and other weird stuff, but right now we want a depth test. And this will be a little bit interesting because I can't remember if I need to change my shaders to make that work, but right now we're just going to go at it completely naive and assume that everything works as if by magic. So when we initialize here, we want to GL enable, GL depth test. So apparently OBS sort of hates me today, which is always fun. Anyways, when we enable sort of this depth test, we also want to do so that every time we render a scene, we want to clear the depth buffer. So GL clear depth, and I think we set this to 1. This is one of those things where it might be 0. And then we do a GL clear, GL depth bit, depth buffer bit. So that clears the depth buffer. So when we do depth testing, it should work. And then we need to set our depth function. So our depth function is GL less. So if we get nothing rendered now, probably done something wrong, as per usual. No, this looks sane. You can see now we are only getting, let me just quickly give you guys the full view here. Now we are only actually getting sort of the part that is nearest us and not like seeing through the cube. So this is our first little wonderful cube. Nice, isn't it? Unfortunately, I think that's where we're going to hold for today. Next week, we're probably going to look at doing a little bit of texturing on this, maybe a little bit more separation, and probably adding a little bit of sort of the, I wouldn't call it level generation, but sort of the pre-steps to level generation. But thank you all for tuning in this time, and I'll see you all again next week.